This robot was programmed to earn a reward point every time it collected dust. It quickly found a shortcut. It started dumping its own dirt on the floor just so it could vacuum it back up again. The robot maximized its score, but the room stayed dirty. It followed the reward instructions perfectly while missing the actual goal. To understand how these systems actually work, we can look at them through a single lens. What teaches the system? Some learn from a list of correct answers. Some find their own patterns in a crowd, and others learn from the consequences of their actions. In traditional programming, a person writes a specific list of rules for the computer to follow. Think of a spam filter where a human types, "If a message contains this specific suspicious phrase, move it to the junk folder." Machine learning works differently. Instead of writing every rule, we provide thousands of examples and a training process. The model then builds its own mathematical patterns to decide which emails look like spam and which don't. Instead of human-like understanding, the machine relies on statistical relationships to estimate what should happen next. The first pathway is supervised learning. This uses examples that already have the correct answer attached. We call these labels. The system studies these labeled examples to learn the connection between the data and the answer. Supervised learning learns from answers. One major task here is classification. This is for when you need to predict a category. It answers the question, which group does this belong to? Is this credit card charge legitimate or fraud? Is this a picture of a cat or a dog? The other task is regression. This predicts a specific numeric value on a scale. While classification picks a group, regression calculates how much or how many, like estimating a house price or predicting tomorrow's electricity demand. Let's try a prediction. A factory has years of records showing exactly which machines broke down and when. They want to estimate if a specific machine will fail soon. Which approach fits best? This is supervised learning because the factory already has the past answers to train the model. Having the answers is a huge advantage, but the model is only as reliable as the data we give it. If the historical labels contain mistakes or human bias, the system will learn those errors as if they were facts. But what if you have plenty of data but no answers? Unsupervised learning works without labels. The system scans the data to find its own hidden structure. Unsupervised learning discovers patterns. Clustering is one way it does this. The system groups data points that share similar traits. A store might use this to find groups of customers who shop in similar ways, even if the store hasn't created those categories yet. Association finds items or events that happen at the same time. If people who buy pasta almost always buy pasta sauce, the system identifies that recurring relationship. It doesn't mean one caused the other, it just shows they usually travel together. Dimensionality reduction is useful for data with thousands of details, like every individual pixel in a high-quality photo. It's like replacing a long 10-page story with a one-paragraph summary that keeps only the most important parts of the plot. Anomaly detection looks for behavior that breaks the normal pattern, like a sudden strange spike in network traffic that doesn't look like any previous activity. Time for another prediction. A business wants to find out if their customers naturally fall into different groups based on their browsing habits, but they don't have any labels to start with. Which approach should they use? That would be unsupervised learning, because the groups must be discovered from the data itself. Keep in mind that a machine finding a group doesn't automatically make that group useful. Humans still have to look at the patterns the system finds and decide if they actually make sense for the real world. We've seen learning from answers and learning from patterns, but how does a system learn when it has to make a series of decisions to reach a goal? This is reinforcement learning. It works in a loop. A decision maker, the agent, takes an action in its environment. It then receives a reward for a good move or a penalty for a bad one. By repeating this loop millions of times, the system learns which actions lead to the highest total score. Reinforcement learning learns from consequences. This brings us back to our cleaning robot. Because the only feedback it received was a reward for dust, it figured out that making its own dust was the most efficient way to keep the points coming in. This shows why designing the feedback is so critical. Since these systems follow consequences blindly, humans must ensure the rewards perfectly match the real-world goal we want to achieve. When we bring these three pathways together, we see the full map of how machines learn. Supervised learning learns from answers. Unsupervised learning discovers patterns. Reinforcement learning learns from consequences. Let's wrap up with a quiz. A company has 50,000 historical emails, and every single one is labeled spam or not spam. They want to categorize new emails. Which approach is this? That's supervised learning. The answers are already in the training data. Last one. A store wants to discover if there are groups of customers with similar shopping habits, but they have never defined any groups before. Which path? That's unsupervised learning, because the system has to find the structure on its own. Choosing the right approach starts with the problem itself. By looking at the data you have and the type of feedback the system will get, you can decide which method is most likely to find a useful solution. Modern AI often blends these three foundations, but they remain the core pillars for understanding how machines gain their capabilities. Which of these three pathways, answers, patterns, or consequences, made the most sense for you? Tell us about a task you'd like to see classified in the comments below. But what happens when the patterns become too complex for simple categories, like understanding a human voice or a high-resolution video? To solve that, we must look deeper into the architecture of AI. We'll see you in the next episode for neural networks and deep learning.